everyone! In today's video we are going to explore the MQTT and WebSockets protocols. We will also learn the difference between these two. Next we will learn how WebSockets can be used with MQTT. Finally, we will answer the question, which one of these two is the best choice for IoT? Let's get going! Let's start with MQTT. MQTT is a communication protocol that defines a set of rules on how IoT devices can publish and subscribe to data over the Internet. It is used for messaging and data exchange between IoT and industrial IoT devices. Let's have a look at its primary features. The protocol uses TCP connections for reliability, fragmentation, and ordering. It aims to minimize the data overhead of each MQTT packet. The MQTT protocol supports bidirectional message flow. This means that data can flow from MQTT clients to subscribers and comments can flow from subscribers to MQTT clients via the same TCP connection. The protocol also supports publish-subscribe routing, which allows the easy addition of more consumers and producers of data. Now let's move on to the WebSocket protocol. The WebSocket protocol was created to enable two-way communication between web applications and web servers, since HTTP cannot do that without workarounds. The WebSocket protocol was standardized by the Internet Engineering Task Force as RFC 6455 memo. The memo is linked below. Now let's explore how you can use WebSockets with MQTT. As WebSockets behave similarly to TCP sockets, protocols which run over TCP can also run over WebSockets. There are many MQTT servers and client libraries which now support WebSockets. The first client libraries to offer support were the ones that run in web browsers, principally JavaScript. The image here illustrates this. Let's have a look at how we can use WebSockets to tunnel MQTT. There is a lot of IT infrastructure geared towards securing HTTP connections while shutting out unwanted TCP traffic. Many organizations are reluctant to open the MQTT standard ports to allow MQTT applications to communicate with the intra-organization infrastructure. The WebSocket protocols solves this problem by allowing MQTT communications to use the already existing HTTP facilities, TCP port 80, firewalls, proxies, and so on. For this reason, many MQTT client libraries which do not run in web browsers also support WebSockets, such as Eclipse PaHoC client. Now let's compare MQTT versus WebSockets. MQTT has a publish-subscribe architecture, whereas WebSockets have a bidirectional socket-like API architecture. The underlying protocol is the same for both technologies. It is TCP. For MQTT, connections are secured via TLS plus username password. For WebSockets, connections are secured via only TLS on the TCP socket. A significant advantage of MQTT over WebSockets is client observability. MQTT allows the client state to be monitored via notifications. For instance, when a client unexpectedly disconnects, users can get a notification of the disconnection. Notifications are not possible in WebSockets. Also, MQTT has an asynchronous event messaging feature. This means that the publishing client does not have to wait until the subscribing client consumes the data. This independence is due to the decoupling of the publish-subscribe clients. Messaging mode is asynchronous in WebSockets. In the MQTT, the broker can queue messages for disconnected subscribers. On the other hand, WebSockets does not have any message queuing feature. Both MQTT and WebSockets have a minimum message overhead of 2 bytes. For WebSockets masked frames, the minimum message overhead is 6 bytes. MQTT and WebSockets can ingest any content type. The message distribution in MQTT is one-to-many and one-to-one in WebSockets. Finally, MQTT provides 3 qualities of service: quality of service 0, 1, and 2, improving reliability. WebSockets, however, does not feature quality of service. So which one of these protocols is best for IoT? MQTT is obviously better for IoT. On its own, for WebSockets to compete with MQTT, all those facilities that MQTT contains would have to be implemented in the client and server applications. Other IoT protocols that normally use TCP could also use WebSockets if the implementations support it. For IoT purposes, you'll find that MQTT does much more than WebSockets, and it's easy to get started. You may want to head over to our full blog post on MQTT versus WebSockets for IoT for a more detailed comparison. Check out the MQTT Essentials playlist to learn more about MQTT. Stay tuned and see you in the next video.